I hope everyone's doing well. I'm Mr. Ish. Thank you for joining me for this video. We are examining a single reaction, organic chemistry over here. We have this reaction here on the top in the condensed form and the same reaction here in the expanded form. Where does the equilibrium lie? Towards the right or towards the left? Everything here is with regards to alcohols. I have here a tertiary butoxide anion reacting with methanol to give rise to tertiary butanol and a methoxide anion. You can see it. You have a anion here and alcohol here and an anion. This right here is tertiary butoxide. Tertiary butoxide. It represents an anion, tertiary butoxide, because you have a tertiary carbon here. A carbon attached with 3 atoms, so it's a tertiary carbon. Here you have methanol. Here you have tertiary butanol, because this butoxide has been protonated, so it's become an alcohol, tertiary butanol. Here's your methoxide anion, and we have to determine in which direction does the equilibrium lie, towards the right or towards the left. So when you're looking at a reaction like this, how do you figure it out? That is, what is it that you're really focusing on? What are the 1 or 2 items you should focus on versus being lost because there's too much going on and then you don't know where to start? Since we're looking here at alcohols and their anions, you should either decide, am I focusing here on the alcohol, the protonated items, or am I focusing here on the anions, which are the deprotonated items? You would be better off to focus here on these anions. Whichever anion is more stable or more likely to occur, it is in that direction that the equilibrium will lie. Look over here, where are my 2 anions? And I'm focusing on that, on the deprotonated items. It's a conflict or a tug of war between tertiary butoxide or methoxide. What do you think is more stable? And the direction of your equilibrium will be towards that. Look over here, I have a negative charge. If I were to draw the oxygen properly with all the electrons, I have 6 electrons, and same thing over here, 6 electrons. What does a negative charge represent? Well, using a negative charge on an atom in organic chemistry represents an excess of charge. And somehow you want to get rid of that excess of charge. And the best way to get rid of the excess charge is 2 means. 1, you can either increase the number of electronegative atoms which are present in that molecule or compound, or you can decrease the number of Now here you're focusing on the electropositive atoms in that molecule. Certainly when you're looking at this and you're looking at this, you're looking at a bunch of carbons and hydrogens, and you know they're more of the electropositive or electroneutral atoms. They're not really electronegative as you would expect. Nitrogen, oxygen, fluorine, and even chlorine. You can put chlorine in there. You're not seeing these. The only oxygen you're seeing is the one which is bearing an excess charge because it has a negative on it. It's an anion. When you're looking at these 2 options, you can either increase the number of electronegative atoms. We know we can't do that because we don't have that option. Then you can only focus on this, decrease the number of electropositive atoms. Why would you do that? Because these electropositive atoms are like electrodonating atoms. They're donating charge towards that negative charge, and therefore they're amplifying it. If you have too much of the amplification of this, then it's bad in terms of stability. You want to somehow get rid of this negative charge of oxygen and pull it away, or you don't want it to be compounded by more charge coming towards it. When you're looking over here, you have 1, 2, 3, and 4 carbon atoms, but you can technically cross out this carbon in terms of your analysis. And you're looking over here, you have a carbon and a hydrogen and a hydrogen and a hydrogen and your oxygen, like this. And let's cross out this carbon. Now we have a tug of war between 3 methyl groups here on the tertiary butoxide, and here we have a comparison with 3 hydrogen groups. What do you think is more electron donating or electropositive? It's these. These are in essence, by virtue of their presence, donating more charge into an area of excess charge. These hydrogens are not doing much because they're technically electroneutral. They're not really adding more into this negative, so I won't even bother drawing dipole arrows. Here, by virtue of these 3 methyl groups, I'm adding more charge into a negative. I'm not able to suck it away, but I'm actually compounding it and adding more. So you know this is becoming a relatively unstable situation because the oxygen is getting too much negative charge, because you're looking at too many electropositive or electrodonating atoms in this compound. Hence, this is not very favorable. This is. Here the hydrogens are not adding much to that negative charge, so it stays as is. Here the methyl groups are adding more, and it's really making this area unstable and too much excess charge. So you know, on virtue of that, this point number 2, since we can't decrease the number of electropositive atoms, and we're just looking at which one has fewer electropositive atoms, and it's this. So your equilibrium will lie here in the direction towards the right, towards this. And again, in this analysis, we're focusing on the anions, not on the neutral molecules, the alcohols. I cannot get rid of this excess charge here on the oxygen because I have no electronegative atoms. Therefore, I must look at the compound here, the two compounds, the anions, where that negative charge is not enhanced further. It's enhanced too much here. It's not enhanced as much here at all. Therefore, the equilibrium will lie in the direction of this methoxide anion, and it exists towards the right. Always remember this. For anions, your analysis is this. Either you have increase in the number of electronegative atoms so you can suck that negative charge away, or you decrease the number of electropositive atoms so you don't add too much charge into it. That's it for this video. Thank you.